I decided to pick this next one because it's also a fun / complicated one. We're asked to determine what's being oxidized, what's being reduced, and of course to do that we're going to start by assigning every single atom on this or in this reaction an oxidation number. And then we of course look at see who's changed from what to what. Potassium chloride, what is their oxidation number? Well, potassium, if you look at the periodic table, is in column 1, which means it wants to lose 1 electron. So unless it's just potassium all alone, it has an oxidation number of +1. So I'll write that down here. It stands to reason that chlorine must have a counter oxidation number of -1, and that also makes sense because chlorine's in column 7. The periodic table wants 1 electron so that it can go to feeling like the nearest noble gas. That one's pretty easy. Let's skip this one for right now and go to O2. O2 is oxygen all by itself or bonded to other oxygen atoms, no charge. What is its oxidation number? Well, yeah, it's totally 0. Let's move over here to the right and knock down the easiest ones here. Chlorine, Cl2, all by itself, chlorine bonded to another chlorine atom, but there aren't any other atoms around. No charge. That also has an oxidation number of 0, so those are chlorines in their elemental or 0 state. Hydrogen must have an oxidation number of +1, and that's indeed the case whenever you have hydrogen bonded to another non-metal, at least almost always. Oxygen, by similar rule I've outlined elsewhere, has an oxidation number of -2. Now the reason I've got this line here that says overall charge is because sometimes it helps me figure out sort of elements that are in between or confusing. You'll note, for example, here there's 2 hydrogen atoms, each with an oxidation number of +1. So together their overall charge is +2. There's 1 oxygen that has an oxidation number of -2. You add those together, that comes to 0, which is the overall charge for H2O. But the oxidation number for each of those individual hydrogen atoms is +1. Combined, they yield an overall charge of +2. Hopefully we're okay with that. Now let's take a look at the hard ones. This HNO3 and the KNO3. Well, I'm going to draw HNO3 out a little bit larger so that we can see it. HNO3 looks like this. Oxygen, whenever it's bonded to non-metals, and pretty much everything else except for peroxides, or if you've got O2. If I've got O2 all by itself, that's oxygen, that has an oxidation number of 0. If I've got an oxygen and a peroxide like hydrogen peroxide, that has an oxidation number of -1. Oxygen, pretty much all other scenarios, has an oxidation number of -2. So I'm going to go ahead and write down my oxidation number here. I've got oxygen having an oxidation number of -2. And then I'll write overall charge. You'll notice that there are 3 oxygen atoms here. Each of them has an oxidation number of -2. So what's the overall combined negative charge from all 3 of those together? Yeah, it's -6. And that's important to keep in mind as we do further analysis here. Hydrogen, if it's all by itself and H2 has an oxidation number of 0, if it's bonded to a metal, then it has an oxidation number of -1 usually. If it's bonded to a non-metal, it has an oxidation number of +1 usually. This is one of the latter cases, so I've got hydrogen here with an oxidation number of +1. There's only one of those hydrogen atoms, so its overall charge is also +1. What is nitrogen's oxidation number here? Well, that one might be a little bit confusing, but we can see that the overall charge for HNO3, there's no charge written up here, so it must be 0. So what that means is that nitrogen has to have an oxidation number such that when I add +1 plus X minus 6, it gives me 0. What does X come out to be? Well, you're right, it's +5. And because there's only 1 nitrogen to give me X, that 1 nitrogen must have that oxidation number. So nitrogen here has an oxidation number of +5. So I'll go ahead and go back up here. I'll write down +1 for the hydrogen, +5 for the nitrogen, and -2 for the individual oxidation number for that oxygen. Let's take a closer look here at this KNO3. KNO3 might be similar. It might not, though. The oxidation number for potassium, and this is usually the case for most metals, except for metals that are in the D block, is going to be corresponding to whatever column it is in the periodic table. Potassium's in column 1, which means it wants to lose 1 electron to have a +1 charge, and hence a +1 oxidation number. Oxygen, for reasons we talked about up here, has an oxidation number of -2. There are 3 of them, so it's going to be -6. So nitrogen, once again, has to have some value that when added to these comes out to be 0, because 0 is the overall charge for KNO3. That also comes out to be +5. So here I've got potassium with an oxidation number of +1. Each of these oxygen atoms with an oxidation number of -2, and this nitrogen with oxidation number of +5. Now what we have to do is look left to right and see what has changed. I've got potassium here with a +1, then that goes to +1. That's the same. I've got chlorine going from -1 to 0. That's a change, so I'll put a little check mark next to that. That's one of the changers. I've got hydrogen going from +1 to, +1 over there. That's the same. Nitrogen going from +5 to +5. That's the same. Oxygen going from -2 to, well, -2 over here and -2 there. Oxygen here going from 0 to -2 and -2. That is a change. That's different. So some of these oxygen atoms that started out as having an oxidation state of 0 got incorporated into either the KNO3 or the H2O and had some kind of change. And so anyway, there's a change. So now that I've figured out which elements have been changed, I have to, dang it to heck, I have to now that I've discovered which elements undergo or experience a change, I have to determine which one's been oxidized, which has been reduced. So let's take a look at our two changers. I've got chlorine going from -1 to 0. Going from a negative number to 0, I'm becoming more and more positive. How does a chlorine become more and more positive or lose negativity? By losing electrons. So if you lose electrons, I lose electrons to become more positive. I lose electrons, that is oxidation. So this chlorine right here has been oxidized. Now let's look at this O2. The O2 goes from 0 to -2. It's going from 0 to -2, so it's becoming more negative. How do you become more negative? By receiving or gaining electrons. They have negative charges. So if I've gained electrons, that is reduction. So this oxygen has been reduced. And that is the answer to the question.